Yes, thank you, Paul. The electron has a negative charge. All right. Now listen to me carefully, okay? In the nucleus, okay, in the nucleus, you have protons and neutrons. So think about the charges of both of those. And then I want somebody to tell me what would be the charge of the nucleus. So you got protons and neutrons, right? In the nucleus. What's the charge of the nucleus? Gibson, what do you think? Or Ethan? Okay, so you got neutral and you got positive in there. Which one's going to override?
Positive.
It's going to be, exactly. So it's a positive charge. Now, what do opposites do? Do they repel or do they attract?
Attract.
They attract. So realistically, okay, realistically, those electrons should be attracted to the nucleus, okay? So if I'm attracted to something, let's just say, Kay, can you come over here for a second? All right, let's just say Cade is the nucleus. Kay's here, okay? I'm an electron, okay? Positive, negative. I should be attracted to Cade, okay? So I'm attracted to Cade. 6 feet, just kidding. All right, now if something wants to pull me away, is it gonna take more energy or less energy to get me away from Cade if I'm attracted to him? Should it take energy, more energy or less energy to get me away from Cade if I'm attracted to him? Somebody tell me.
More.
It should take more energy. If I'm already attracted to him, that's where I want to be. If an electron is attracted to the nucleus, it wants to be over there. So for me to get it away, I have to add energy for me to get away from it, okay? So that's the same thing that's happening with electrons. They want to be near the nucleus, we have to put in some energy to get it away. So for us to get them excited and to jump from, like, let's just say ring 1 to ring 3, we have to add energy. And that's what we're going to do today. This is the science behind how fireworks work, okay? So Kate is going to be my band white today. I don't even know if you guys know who that is. All right, we're going to turn the screen this way. All right, and we're going to do a little demo. Let's see if I can bring it close enough. All right, Kate.
That's as far as you can get.
That's as far as it can go. All right, Kate, I want you to, let me see if this light is off. All right, so I want you to go turn off the other light.
Okay.
If you were here, safety first. So I'm gonna put on my goggles. This is gonna be a demo. Kate's gonna be my cameraman, okay? All right, Kate, you're gonna hold this camera so they can see. There you go. All right, so over here I have a Bunsen burner, okay? And we have a couple of different compounds. Somebody, let's see. Mandy, do you remember what a compound is?
2 elements, maybe.
2 or more elements. Excellent, okay? Let me just turn this up so I can hear them. Excellent. Okay, so I have some compounds over here, 2 or more elements. The metals, okay, the metals that are in these compounds is the electrons, have the electrons that we like to excite. So I'm going to turn on the gas here. Oops, that one went out. So what we're going to do is these compounds, oh, I didn't pull one out. These compounds, they have metals like lithium. All right, you guys can see that flame, yes?
Yes.
Good. All right, that's a lot of gas. I'm going to bring this down because that's a really big flame. There we go. All right, so I'm going to take all those metals have electrons, okay? And I'm going to excite those electrons. I'm going to excite them by lighting them on fire, okay? So when I excite them, because they're different metals and they jump up, we talked about wavelengths, okay? So depending on how far they jump, how much energy they have, they will put off different colors. So this is kind of like the science behind, again, fireworks. So let's try this first one, all right? This is how you know if a flame is really hot. If it's more yellow, it's hot, but the bluer it is, okay, so like this is hot, but this blue one is way hotter, okay? So I'm gonna make this more blue. All right, and if you can see, can this come a little closer? That's closer. All right, you can see there's an inner blue flame in there that's even hotter, okay? All right, so here's the first one. This one's called strontium chloride. So the metal is strontium. Here we go. Can you guys see the color on it?
Yeah.
Let's see.
I don't think it was going through very well.
Should be a nice.
Can those blinds be closed? I think they're causing
Yeah, let me see if
confusion.
I can close this blind and turn this light off. We're trying to get it as dark as we can for you guys.
You want me to go do those?
I think those are be fine.
Okay.
All right, so I'm gonna try this one more time. So maybe you can hopefully see the color. All right, I'm gonna pull it a little closer to Kate.
Okay.
All right, here we go. Oh, did I, there we go. All right, so that's a nice red color. That one was strontium, okay? All right, let's try this barium one. Let's see what this one's like. This one's like a yellowish color. I hope you guys can see the color on it. Can you guys see the color? Or does it just look like flames every time?
I can see it a little bit.
See the color a little bit? Maybe if we try to make the screen dark. It might be the screen too. So let's turn
Yeah, I
it.
think I see it turn red. It's blue.
Oh,
Yeah.
there we go. Don't worry about it. Leave it just like that. Oh, that's where that came from. All right, I'm just trying to get the light from this screen off.
If I angle it more.
Me and Kay are trying to work out our theatrics here. All right, so here is potassium chloride. So the metal is potassium, all right? This one's a nice pink, purple, peach-ish color. Okay. Let me find a good one for you guys. Probably should have made sure that was that. Here is lithium. Okay, blue flame. Nice red color. This one's pretty red. You can't see it. Hopefully you can. All right. My favorite, oh, did I just do potassium? I did potassium. This is my favorite. This one is copper chloride. Here we go. Nice green color. Okay. And again, this is the science behind fireworks. This one is sodium. So this metal is sodium nitrate. This one's a nice bright orange. Okay. And we got one more calcium. Okay. So usually I would just have it super dark in here and you guys could just play with these. Let's see. This one's also kind of an orangish color.
Mm-hmm.
All right. All right. So here's what we're going to do today. Unfortunately, we didn't do the calculations. All right. And we can't, did I do strontium?
I don't think so.
All right, let me do strontium. I got one more. Sorry. All right, here's strontium. This one's a nice, kind of a reddish orange color. Okay. All right, so here's what we're gonna do today. Thank you, Cade.
Mhm.
I'm gonna turn this off now. Ugh. No, can you hit my light for me again? All right, so here's what we're gonna do today. Unfortunately, we'll have to do the virtual version of this lab. So, thank you. Somewhere in the back.
You're gonna have to bring it back closer. maybe a
Okay.
little bit.
See it? I just realized I just broke this off earlier. I'll fix it. All right. So, I can't figure out where I am. There we go. All right. So what we're going to do is we're going to do a virtual lab. Okay. I'm going to give you guys a link. Okay. The link will pull up a lab that looks like this. Oops. Give me 1 second. All right, let me go back out of this. Oops. Hold on, trying to get out of the screen. Ugh. All right, it's gonna pull up, and I'm gonna put in the chat just to make sure. It's gonna pull up one that looks like this. You're gonna hit full screen, okay? And this is why I want you to work in groups, okay? You're going to be able to move the wand just like I did in and out of the flame. You can see there's a model of an atom over here. Here are your different compounds at the bottom. Okay. And you notice each compound starts with a different metal. Okay. So for instance, anybody know what Ca is? What is Ca? What metal or what element? Calcium. Very nice. Okay. So once you click one, you can take it. Remember, copper was my favorite. Slide the one into here, and you can see, the different colors. If I could operate correctly, okay, you can see the different color flames. Okay, so there's a couple of questions about it. Here's the different ones. Okay, you want to work in a group so that you can see the different ones. Okay, let me also show you. So in a second, I'm going to do breakout rooms. Somebody can have this up on their screen. Okay, somebody can have this up on the screen. The other person or people can have up the virtual flame lab. The other person who has it up on their screen can have it up too, obviously. So it's going to be the virtual flame lab, okay? And you're going to answer the questions, okay? Now, some of them are about wavelength. Some of them are about frequency. Some of them are about color. It just depends. All right. Okay. All right. So I'm going to put you guys in breakout rooms and you're going to work on that lab. You want to make sure you just kind of read the questions carefully. Okay. When you're in your breakout rooms, if you need help with something, you can just request it. I think at a minimum, you should be able to finish the lab this period. Just be very careful. Just make sure you're paying attention to the questions. The ones that I see people missed, like first block, it wasn't because they didn't do it. They just probably kind of read too fast, okay? All right, any questions before I put you in your breakout rooms? If at this point now, you know that you would like to be in a breakout room with someone and work on the lab together, I strongly suggest you guys work together, strongly suggest. Then you can send it to, just put it in the chat and I will put you guys in the same breakout room, okay? So anywhere between 2 and 3 people. Yes, and I'm gonna open up the lab in just a second. Okay, I'm going to do breakout rooms first, and then I'll open up the lab. All right, so you can send me a chat about that.